we are now go over Entity Practice Exam 2006 for question 12, part D and E. Based on part A through C, we already figure out what is the oxidation part, what is the reduction part, and we also balance the reaction. I just also put the voltage on it, by the way, because we'll need a calculation of the total cell in part E. It's already been fixed in the way that it is the best. So I'll say pretty much part E is just adding them up. Now here's the game of how to draw them correctly. I think it's quite obvious because I will give out electrons, okay? And this part will be zinc solid, will form zinc ion aqueous. On the other side, because I will have electrons coming in, this is where the electron zinc lost. It's being accepted by VO2 plus, so it will be VO2 plus gets into V3 plus. Okay, actually, because both of them are aqueous, so all of those is in the same flask. Okay, the pink part means it's aqueous. Okay. Now, what's the possible electrode for this one? Palladium, PT. Yes. Because all of your redox happens in aqueous. Instead of a real solid, you should use whatever electrode that's being provided. Are we cool with this? Okay, what am I missing? Yeah, salt bridge. Okay. So I have a positive here. I will need Cl minus. Can be any others. Can be nitrates, whatever. As long as they don't precipitate. Cool? Okay, what do I have here? Because I'm getting less positive, so I will need more positive. So you can put potassium, you can put sodium, whatever. So you can choose the salt bridge as long as they don't precipitate. Okay, we do have a question. I think last week this time we went over a similar question. It's very unfortunately you choose a wrong one that's going to precipitate. That's not going to work. Okay, and we also tied that one with KSP. Yes, that's last week's video. If you're interested, you can check them out. We explain why we cannot choose a precipitating here. If we choose, okay, let's say, if whatever cation is going to form precipitates with that, what you're going to see is here is going to get a lot of solid crowded in, and it's going to block your bridge. That's not going to work. We want the electron to flow. We want the cation anion to flow. Are we cool? All right. That was part of the previous year. Just if